Exercise 28 on page 57 in the text. Further problems on partial fractions with linear factors. And question number 1 is a special case. This particular denominator, x squared minus 9, is an example of a special case. I'm not going to look at this one, I'm going to look at one very like it, so you can then look at the one in the textbook and see if you can get the answer there. What we're going to look at is here, 24 over x squared minus 16. In denominators like this, we can use this method called the difference of two squares here. And it only works if there's no term involving x in the denominator and the number is negative. The number is negative. And if we look back at our example, we can see that is true in this case. We've got no term in the denominator involving x, and the number 16 is negative. So to use this method, what we do is we square root the two terms, the x squared and the 16. So the square root of x squared is just x, and the square root of 16 is 4, and that gives us the two terms in the brackets, x plus 4 and x minus 4. These brackets are pretty well identical, except one's positive and one's negative. If you multiply out these brackets, you can see that that in fact gives us the term x squared minus 16. So to factorize examples like this is quite straightforward. It only works though if there's no term involving x and the number is negative. For example, we could use this method to factorize this because there's no term involving x and the number is negative. So we just need to square root these two terms and then put them in brackets, one positive, one negative. What do you think that would be? Have a go. If we do it, we can see that we get 3x plus 5, 3x minus 5. The square root of 9x squared, square root of 9 is 3, x minus 5 and plus 5. Can you see why this works? When you multiply out the brackets, ask yourself the question, why does that always work? Why does this have to be negative? So going back to our original problem then, because we've got this particular denominator in this special case, it's easy to factorize and to therefore get the two terms, x plus 4 and x minus 4. So to go back to solving this and turning it into partial fractions, we can now see that we can write it as two terms, some constant a over x plus 4 and another constant b over x minus 4. And so what we need to do now is to work out what these values of a and b are in these two partial fractions. So the first step, looking at the right hand side, is to recombine these two fractions, remember, to get the common denominator. And to find the common denominator, here we multiply these two terms together. So now what do we do to get the numerator? Have a go. The solution follows. If we look at it, we actually multiply a by x minus 4, so it's like cross multiplying in a way, a multiplied by x minus 4 and b is multiplied by x plus 4 to give us these two factors. So that's what the numerator will now look like. Can you remember what we do next and finish the problem from there? We have to equate numerators. So equating numerators, we get ax minus 4 plus bx plus 4 equals 24. The numerators on the left hand side and the right hand side can be equated because the denominators are the same. So now we've got to calculate the values of a and b. And there's two ways that we can do this. We can either expand the left hand side, collect together like terms, and then equate coefficients to find the values of a and b. Or we can set values for x. We can assign a value for x, which means that one of the constants, a or b, disappears, and then we can solve for the other constant. And then once we've done that, we assign another value to x to find the other constant. I'm going to now do two videos to show the two methods. Sometimes one is more convenient than the other, so it's worth looking at both. And remember, of course, that these two methods provide the opportunity to practice your algebra skills, which is what basically it's all about anyway, isn't it? So see if you can carry on and complete this question, maybe looking at these two methods. And if you need help, there's two videos that will follow this that will help you.